Hello, welcome to the channel. So let's talk about event sourcing pattern today. Although there are tools like Datomic and XTDB exist, sometimes you're just not ready to commit to a tool like that, and to dive into unknown. So probably you'll find yourself in cases when you have agreed data store, something like relational database, MySQL, Postgres, but you still want to try event sourcing pattern on top of that. So that's what we're going to look into today. Is it possible to use Postgres in our case, and how good it will work with Clojure language as our main backend language. Before we start, I just wanted to share that I started a Substack and I write some posts there. I'm trying to post more than on YouTube, some different topics, but my YouTube videos will be kind of in a text format there, so feel free to subscribe if you prefer to read, and the link will be in the description of this video. So if you're not familiar with what is event sourcing pattern is, just like a really top level view is, instead of doing mutations of your state in your data store, when you have like a row that represents the state of your entity, like order, and then you have field status, and in classic approach, you just use that row as your source of truth, and then you update the fields in place. So you have like a mutable state in your database. In general, event sourcing is as simple as a log of events ordered by time they were created, and those events are immutable, and they represent the system state. And then when you calculate or materialize one of the resources, you get all events that describing changes of that resource, and you apply some rules in some service or somewhere to combine those events into a single row that will now be your the state of your resource. And there are a couple advantages of this approach. The first one is that if you don't mutate anything, you just basically insert, like append only mode. So the writes are much more cheaper. So you just insert new events as you have them. And also, as you have the full history of events, you can replay them. So for example, if you bring a new service, microservice to your system, you can just subscribe to history of all events from other services, as it was always in place, this new service, and you just replay the full history and build the microservice vision of the state as you need it. And also things like time travel are possible when you can query how your resource looked in particular point of time, just getting the portion of your events, not the full history, but just like up to some time, and just apply same projections on top of that. So this is in a nutshell. We're going to implement a simple example in Clojure. I prepared some code, so without further ado, let's jump into the editor. So here we go. I have a new migration. We're going to use Postgres, and we're going to just basically focus on a simple test, and we're going to use test containers to spin a database. And this my test is set up in that way that when I create data store, these migrations are applied. So this table will be available when we run the test. So what we have here, we have the ID that will be event own ID, just unique UID, and we use Postgres mechanism to generate random UID. Then we have type, and this is a type of event itself. Let's talk about that in a sec. So then we have two really important fields. One is aggregate ID and aggregate type. This could be called different. So I've seen entity ID, entity type, stream ID, stream type, something like that. just for simplicity here. This naming is used, for example, in Outbox partner in Debezium, but you don't have to know that. So we have these two fields, and then aggregate type will mean the type of the resource. So example will be here, for example, resource is called order or card or customer or user or account, something like that. And then we have aggregate ID, which is ID of that resource. And after that, in this stream of events, we can have multiple events with different IDs, and all of them will have different types, or maybe some similar same types, how we design that. So the type in this case could be something like, for example, for order created, order approved, order dispatched, something like that. And for user created, user detail updated, user blocked, whatever. So yeah, and then the main bit is this payload, and here we basically combine features of relational database, what it provides, with a bit of flexibility that NoSQL databases provides. When you have so in this case we'll have a separate column called payload, and we use JSON data type there, so we can put whatever data we want in this field related to this event, and this data will be used later in the code to build and update the state of the resource. And then created that just to have the idea in which order events were inserted into the database, and it's much more convenient to use some field from the top level and not rely on a similar field from the payload. But probably you can use payload and put some updated add field there as well. Okay, so that's our database table structure. So now let's jump into the test. I think I can close this one. And yeah, this will be our final test. We'll start from scratch. I created a simple version of that here. So let's reload this namespace and try just run this thing. So here we just have a simple assertion that pass, and after that we'll start our real test. So what we have so far, we create a database container with test containers for Postgres 15, and then we start it, and then we have this custom macro with system, and here we define our system that only contains of our data source to connect to the to So in this system under test, we'll have a key called data source, and we'll use that to connect to get the connection to the database. And yeah, finally we're just stopping test container, and that's it. So yeah, let's take a look into how we insert events into our events table. And to do that, we want this function, actually a couple of those as well. Let's move them to the top and let's see what we have. So here we're using SQL in Clojure to build our SQL queries. And let's run this in REPL so you get the idea. So we can get this bit, and then we'll instead of this we'll just add a map, something like ID1. What else fields we have? Like type, order, created, for example. You see we just generating an insert statement with these values. Okay, so yeah, it's just simple insert. The only thing you need to know here when you working with JSON fields, you want to update it so JDBC, NextJDBC knows that you're inserting a JSON, and to do that, the easiest way is to create a PG object and set type to be JSONB and set value. But then we have this map that we have as our payload, and we encode it into a JSON string. So let's say we have our map, ID1, type, something. And we have our encoded string as JSON. And then NextJDBC just inserts that into the table without any problems. Okay, so that's good. Let's now create a couple events and we'll try to insert them. So I prepared a couple events. So we'll work with our entity called order, and then we create order ID and custom ID at the top. And then we create a couple events. And the structure is, as you see, aggregate ID, aggregate type, and payload. And in payload, we just have some random data. The thing that we'll use in future is this custom ID to build some custom queries. Okay, so first of all, we have order created, and aggregate type will be order in all cases, and then the type of the event will be order created. Order paid. Just like we have order paid type here and different payload, order dispatched, again, different type and different information in the payload. And then just for some tests, I created other order ID and just inserted the order created event. And after that, we just want to call our insert event system.test, and then we want all of those events to be inserted. So we can do something like that. Again, I don't want to type, so I'll grab that from here. Okay. Let's see. All right. Yes. Let's move our assertion inside the let. It should still work. Yeah, no failures. So something happened here, but we don't check that we're getting something. So what we can do is we can try to get an event by ID. And I think I have a function somewhere here. Get by. So yeah, this will be used to get by aggregate ID. Just let's create a separate one now to create just a single event by ID. So let's put it here, by ID, let's say ID, and now we need to update select query, so it will be where ID equals ID, and we don't want order in this case. Okay, let's remove this, and for now we can just comment out this thing. So this will be just event. And we want to return it, so probably we just want this here. Looks good. And okay, so now we're testing that can get event by ID from DB. Let's say let event from DB, and we do get by ID. System.test, and then so yeah, as our database generates UID, we want to get one of the IDs here. So let's move inserted event here, so we can get which like the ID that was generated. So we can do this, and let's for now remove this block. And let's just see what we have inside our inserted event. Yeah, I just usually compare to something. So see it, right? Let's run. Okay, and we have ID of the event here. That's good. So what we can do is, yeah, we can just name it like this, and after we can use ID from that here. So it will be now ID, and then inserted event. And yeah, let's just compare again, same pattern to something, just to see what we get back. Event from DB. Let's see if that works. Empty. Okay, interesting. Okay. All right. So this is a vector with one element. I think I just need to fix the GDBC here. Execute one probably, right? Yep. Let's try that again. Okay, that's better. So now we have Neil. Oh yeah, so yeah, actually I updated the wrong place. So execute one should be here now because that's the insert function that we using. Let's try that again. Yeah, so we have now the map. That should be good. And here, yeah, we got the event here. So event from DB. Yeah, let's keep it simple. So we just want to compare that ID of inserted event is same as ID of event from DB, which makes sense. And after that, we just want is something like some event from DB. Let's run this thing. Okay, and we have everything passing. That's good. But getting event by ID is probably not the most interesting part that we can do. And now let's add this test assertion and we see what's going on there. Right, so here we will try to get by aggregate ID now. So we will get all events by order ID, but it will not be the list of events. We want to combine them as we discussed. So we will have list of events and we'll start from the earliest one and we'll apply our custom apply event function to build the final state of the resource. So to do that, let's go back here and uncomment this aggregate by ID function. And now you see we have this project function at the end. And we actually need to bring that from here. To do that, let's kill this one as we don't need it. And let's grab this thing and move it somewhere to the top. So core of our logic will be this multi-method. So it's called apply event, and it will take two arguments. First one will be current state, and then the event that we're trying to apply to that state. And this function basically interested in the type, which we'll use in def method. And we're basically going to create a keyword or like a keyword of aggregate type /type. And here we're just registering our individual apply events for all the types that we want. So we have order/order created, order/order paid, order/order dispatched. And as we know that this event will be always the first one in the list of events for a particular resource, we can ignore the initial state and we just build initial state from here. So we're just saying like resource type, aggregate type, and then we get order ID, which will be aggregate ID. Created at will be created at of the event. And then we just merge all the fields from the payload. In real world, you probably want to do some picking of different data from the payload. You really don't want probably the entire payload to be a state of your resource. But just for simplicity here, I'm just going to use the entire payload. All right, so that's the first event in the chain. Then we have order paid. And here we actually use the state. So it is, if you're familiar with like something like reduce function in Clojure, it's the same thing. The state will be kind of like accumulator, and then we apply our apply event function on top of that, plus the event that we receive now. So here, interesting thing that we adding this updated at field, and updated at is actually created at of the event itself, of the event that we're trying to process now. And then again, for simplicity, I'm just putting the entire payload to the final resource. Probably you want to pick some fields, as I said, and put some fields only. Again, exactly same logic for dispatched. Yeah, you can create like a simple function that could be reused here and here. As I said, usually those events, the body of those apply events for different types will be actually different because you want to pick data that you want. Okay, so and then you see this reduce. That will be the main thing that we have. And we have apply event, the function that we're going to apply, state and list of events here. So when you call it with just events, the original state is just empty map, but we anyway ignore that. So it could be nil or whatever. And then we do reduce, and the result will be just single map representing the state of the resource. And yeah, here we have the get by aggregate ID function. So the query is simple, right? We have where aggregate ID equals aggregate ID, and we want to order by created at. Then we get the list of events by this query. And then we do, yeah, this is a bit annoying step, but you have to do it the opposite conversion from JSON-B to Clojure map. So I'm basically just getting the value of the object and then decode it with true. This is like a Cheshire library here for simplicity, but it will convert keywords, keys to keywords back. And yeah, then we call project. So project will take events and it will apply in order of created at the transformations that we just saw here. All right. That's how it's supposed to work. So let's uncomment this thing and we'll see what we have. So this is our final resource, like final order when all events are applied. And you can see that the status is dispatched because the final event was dispatched. And also we have different fields from different events because we merge the payload always into the resource. So we see the payment method card, which comes from order paid event. Then we have this tracking number for dispatched, and the updated at will be the update created at of the final event, and created at will be created at of the first event in the chain. Cool. And also we checking here the other order. So we're getting it by the other order ID, and the status is pending because this status is set in the original event, the order created. Okay, cool. So let's remove this, and we're going to the final example. So what we have here is, for example, we know what we've seen so far is how you get event by ID, or how you get a list of events by aggregate ID or entity ID. But what if you have a query that, for example, you have your customer ID or whatever other data you're interested in inside the payload itself. So you want to create a query, something like, give me all orders for particular customer ID. And this customer ID lives only in payload of one of the events for the customer. So here things getting a bit tricky. So I actually in this post I provided an example of the simple query that you can imagine as the first in the first go. So in this inner select, we're just selecting aggregate ID, where payload and these arrows is to get inside the JSON payload in Postgres and do a lookup. So where custom ID field inside payload equals to custom ID, and then aggregate type is customer. In our case, it will be order, but whatever. And then we use this where aggregate ID in this, because we now want this select will return only events where the payload contains this custom ID. But what we actually want is for all different aggregate IDs, we want all events so we can apply projections properly. We just found out that this is not the most performant way of doing that in Postgres. And this select query that looks a bit more advanced actually leads to better results in terms of performance. And what happens here is we doing a self-join on the same table. So we just name it E1 and E2, but it's same events ID. And we're doing the cross-join by aggregate ID. And then when the payload of E2 contains custom ID, we'll just return all distinct E1s. And this actually means that we now return all events, so we don't have to do where in statement, which tends to be slow in Postgres. Okay, so let's try to implement that. So we have the query here. I just used like a plain string for simplicity. So distinct E1, we get all fields from there. We do inner join on E2 by aggregate ID. And then this is the query that we want by custom ID. And after we get these events, now they will be for different aggregate IDs, right? So the thing that we want to do is, again, we do the transformation for the JSON, but then we want to group by ID. So now we split our list of events into groups of the events that belong to individual resources. And then we get the values and doing the sorting, so we maintain the correct order of the events in these groups. Actually, you need to reverse that. So you can write it better than this, but whatever. And then finally you do project. And the result of this is not one event now, but the list of, not one resource now, but the list of resources. Because in our case, the custom ID was the same in our first event, right here, custom ID, and then in our second order, same custom ID here. So actually, we expecting it to be two orders there. So let's grab this thing, and we can put it somewhere here, right? And let's run this. See, it works. And if we remove, just let's see what we have. So we have two elements here, and as we've seen, this was our first order, and this is our second order right here. All right, that's all I wanted to share in this video. Thanks a lot for watching. Don't forget about the Substack, all links in the description. And also there is a link to the source code if you want to go through this example yourself. Don't forget to like, subscribe, and share. And as usual, you can support me on Buy Me a Coffee. Again, all the links are in the description. Thanks a lot for watching. See you next video. Bye-bye.